Hi chemists, this video is a series of examples of redox reactions and balancing half equations to form a full redox equation. I've got three problems. Oh, there's an extra page in there. But I've got three problems to work through, a little bit of a revision, and on each page down the bottom right, I've given this handy little step-by-step guide for us to work through. Okay, problem 1. Iron 2 reacts with the permanganate ion, MnO4 minus, to produce iron 3 and the manganese 2 plus ion under acidic conditions. Give a full equation for this redox reaction and identify the oxidizing and reducing agents. Okay, so first thing that we need to do is number 1, pull out our half equations or our half reactions. So find the common partners between reactants and products. So here we've got iron 2 going to iron 3. So I'm going to start to put a half reaction there. Fe2 plus going to Fe3 plus. Okay, and the other half is the permanganate ion going to the manganese ion. So underneath MnO4 minus, I'm going to leave a space because I'm going to need to add some stuff in to balance this out. And it goes to the Mn2 plus ion. Okay, what we can do is we can stop here before we start balancing, and we can decide what's being oxidized, what's being reduced, and from there, what is the oxidizing and reducing agents. So I'm going to switch to red to keep it a bit separate. So oxidation numbers, remember that for a monatomic ion, it's just the charge on the ion. So that one's 2 plus, that one's 3 plus. So it's increasing, so it's oxidizing. Okay. So remember, oxidizing is loss of an electron, so it's lost an electron there, and we'll see that when we balance it. We can do the Mn2 plus easily, that's just 2 plus. Remember though, for the permanganate ion on this side, that the sum of the oxidation numbers for all the atoms present equals the overall charge on the polyatomic ion. So the overall charge is -1, and it's going to equal the sum of the oxidation numbers of 1 Mn plus 4 times O. Okay, and that all equals -1. Remember that oxygen, in the majority of cases, there's a couple of exceptions, but the majority of cases it's -2. So let's substitute that into our algebraic expression. 4 times -2, which equals Mn, not plus, -8. Add 7 to each side. Oh, sorry. Add 8 to each side, which equals 7. My brain is trying to go too quick and not taking it slow. So the charge, the oxidation number on the manganese this side is 7, and it goes down to 2, so that is reducing. So that is gaining electrons. Okay, so if Fe2 is being oxidized, it is the reducing agent. It is causing the reduction of the permanganate ion. So it's the reducing agent or reductant. And the thing that is reducing is the oxidizing agent. So the permanganate is the oxidizing agent, or the oxidant. Okay. It's like flipping it around. But remember, they're both reactants, so they're both referring to the Fe2 plus is the reductant, and the permanganate is the oxidant, okay? All right, so let's start again underneath. I might just draw a line, and let's balance these two half equations. I'll switch back to black. So for the first one, iron 2 plus going to iron 3 plus. This is a bit of a simple one. Okay, balance any non-hydrogen or oxygen atoms. Okay, we've got iron in here, which is not hydrogen or oxygen. There's one atom on the left and there's one on the right, so we're balanced. Balance any oxygens? We haven't got any oxygens. Balance any hydrogens? We don't have any hydrogens. Balance any charges by adding electrons to one side. Okay, we've got different charges. We've got 2 on the left, 3 on the right. And we need to add in enough electrons so that the charge is equal. Now, electrons are negatively charged, so you want to find the smallest one, which is the 2 plus. Okay, so on the opposite side, we need to make that 2 plus. So we need, it's 3 plus, so we need 1 electron to bring it back down to 2 plus. Okay, that's balanced that half reaction. Now let's do the permanganate one. MnO4 minus, and leave a bit of space, Mn2 plus. Okay, let's start at number 2. Balance any non-hydrogen or oxygen atoms. Well, 1 manganese on each side. We're balanced. Okay, balance any oxygens by adding waters to the opposite side. We've got 4 oxygens on the left with the permanganate, so we need 4 oxygens on the right. So we need 4 waters on the right. 4H2O. Okay, now number 4, balance any hydrogens by adding protons to the opposite side, H pluses. Okay, we've now got 4 waters on the right. There's 8 there's 8 hydrogens. So we need to balance that out with 8 H pluses on this left-hand side. 8 H plus. Okay. Now we should have the same number of atoms. Yep. 2 manganese, 4 oxygens, 8 hydrogens. Yep. Now we need to balance the charges by adding electrons. Okay. I'm going to swap to red and count up my charges. On this left-hand side, I've got a -1 and a +8 because 8 H pluses, so that's +7. And on the right-hand side, water is neutral, manganese is 2 plus, so +2, okay? I need to bring down the left-hand side to equal the right-hand side, so I'm going to need 5 electrons, okay? 5 electrons will bring that down to +2. So I'm going to 5 electrons added to that side. All right, I'm just going to erase my working out. Whoa, went too far. That's better. Okay, so once I've got the both half equations, we need to make sure that one is producing electrons and one is consuming electrons. So look at the iron 2 plus. It is losing an electron, so it's donating electron, and the permanganate is consuming 5 electrons. So that's good. The electrons are on opposite sides. That's promising. If they're on the same side, you've done something wrong. Go back. Okay, one is giving, one is gaining. That's good. Okay, so remember that this one is oxidizing, this one is reducing. What we need to do now is, before we combine them, we need to combine them in the right ratio so that the right number of electrons are being given as they're gaining. So the first equation is giving 1 electron, but the second equation is gaining 5. So we need 5 times the first equation to give the 5 electrons for the second one. So what we need to do now is, to balance it, we need to stoichiometrically multiply that first one by 5. Okay, so what we're going to do, I'll just scribble on here because it's good. I'm going to put a big 5 out the front, a big 5 out the front, and a big 5 out the front there. A bit messy, but that's all we need to do. Now that one's giving 5 electrons, one's taking 5 electrons, what we can do is add the 2 equations together. That means adding both sets of the reactants with both sets of the products, okay? And I've just got one overall arrow here. So what do we got? We've got 5Fe2 plus from the first equation, plus 5 electrons from the second, plus the permanganate, plus the 8 H pluses. On the right-hand side, we've got 5 iron 3s plus 5 electrons plus Mn2 plus the 4 waters. Okay, now what we do is cancel anything that appears on both sides. Okay, hopefully you should at least cancel all your electrons out of there. 5 electrons on the left, 5 on the right. Okay, iron 2 plus 3 plus, everything else is different. Okay, there's no common things there. So what we can do is rewrite our equation as our final answer without those electrons in there. 5 Fe2 plus the permanganate plus your 8 H pluses reacts to form 5 Fe3 plus the manganese 2 plus the 4 waters. And that is our balanced equation. Also good practice to put states in here. So these would be aqueous, 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 and liquid. Okay. Probably should have done that all the way through, but that's okay. Maybe I should do it for this one. Okay. Example 2. The chlorate ion, which we're giving you the formula there, it's not one you have to remember, reacts with iodide to form solid iodine, or iodine, and chloride. Give a full equation for this redox reaction. Identify the oxidizing and reducing agents. So the same process, different reaction. Okay, let's pull out our 2 half reactions. I've got chlorate going to chloride. ClO3 minus, Cl minus, aqueous, aqueous. And what's the other part? Iodide going to iodine. Iodide, I minus, aqueous, going to iodine. Oh, it's a diatomic, I2, and it's solid at standard temperature and pressure. Okay, what's being oxidized, what's being reduced? Let's assign oxidation numbers here. Okay, this one's nice and easy, -1. This one's nice and easy, 0. This iodide is nice and easy too. It's a monatomic, so -1. And let's work out the oxidation number on the chlorine in the chlorate ion. So the sum of their oxidation numbers are going to equal the charge. So the charge is -1. It's going to equal the oxidation number of chlorine plus 3 times the oxidation number of oxygen. Chlorine plus 3 times -2. Expend it all out. Chlorine minus 6. So we're going to add 6 to each side. So chlorine oxidation number in this is +5. All right, I'll just erase that to give me more room. Okay, so the chlorine in the chlorate is +5 and it's going down to -1. So it's being reduced. And the iodide is -1 and the iodine is 0, so that's being oxidized. It's increasing in charge. Okay, so the one that's being, the chlorate is being reduced, so it is the oxidizing agent, or the oxidant. And iodide is being oxidized, so it is the reducing agent, the opposite. It's causing the reduction. Reducing agent or the reductant. Okay, let's balance these 2 half equations now. And hopefully all our electrons work out and we can check that. So ClO3 minus going to chloride. Okay, let's balance this one out. Any non-hydrogen or oxygen atoms, well, we've got 1 chlorine on the left and 1 on the right, so we're all good there. Balance any oxygens by adding water to the opposite side. Well, on the left-hand side in the chlorite, we've got 3, so we're going to have to add 3 waters to the right-hand side. Okay, any hydrogens we're now going to balance by adding H pluses to the opposite side. Well, we've just added 3 waters, so we have 6 hydrogens on the right, so we're going to need 6 H plus on the left. Okay, all of our atoms are now balanced. Now we need to balance charges by adding in electrons. So switch to red. We've got 6 plus minus 1, so that's 5 plus on the left-hand side, and we've got 1 minus and 0. Okay, so we need to take this 5 plus all the way down to negative 1, so we need to add in 6 electrons on the left-hand side. 6 electrons will take this plus 5 down to negative 1. 6 electrons. Okay. Let's do the iodide to iodine one. Iodide to iodine. Okay, don't forget this first step. Balance any non-hydrogen or oxygen. We've got 1 iodine on the left, but 2 on the right. So we need to up that to 2 iodides. Okay, now balance any oxygens, there are none. Balance any hydrogens, there are none. Balance any charges. Okay, let's switch to the red for charges. We've got 2 minus and 0 on the right hand side. So we need to add in 2 electrons to the right hand side to bring it down to 2 negative. Plus 2 electrons. Okay, and this is reassuring too that we've put it on the right hand side, because in the other half equation with the chlorate, electrons are on the left-hand side. So, let's look at the number of electrons to see how we can smash them together. So, one lot has to give up as much as the other lot takes. So, the first equation is taking 6 electrons, but the second equation, the iodine one, is only giving 2 electrons. So, to give 6 electrons, we need to multiply the second one here by 3 times the stoichiometry, okay? So I'm just going to up that to 6. 2 times 3 is 6 in front of the iodide. There's a 3 in front of the iodine, and this 2 electrons now gets multiplied by 3 to get 6 electrons. 6 electrons. Okay, now we're all good. We can add them together in the right ratio. So, adding all the left-hand side. 6 electrons plus 6H plus the chlorate. Oh, I'm not putting my states in. That's terrible. I might leave a bit of room too. Sorry about this. 6 electrons. Electrons have no state. 6H plus aqueous plus the chlorate aqueous plus the 6 iodides. Okay, and we've got the chloride plus the 3 waters plus the 3 iodines, nearly said iodide, and plus the 6 electrons. Okay, hopefully our electrons should cancel. Let's take a look. 6 on the left, 6 on the right, that's good. Can anything else cancel? No waters, no. We all look good, so nothing else can cancel. I'm going to write it all underneath together. So, 6H plus aqueous plus the chlorate plus the 6 iodides produce chloride, 3 waters, and 3 iodines. Okay, so there's our balanced half. Sorry, not our balanced half, our balanced full. And we've worked out that the chlorate is the oxidizing agent and the iodide is the reducing agent. Okay, one more example. Sulfide reacts with nitrate to produce solid sulfur and nitrogen monoxide gas. Give a full equation for this redox reaction and identify the oxidizing and reducing agents. Same process, same question, different chemistry. Let's pull out our half equation. We've got sulfide going to solid sulfur. S2 minus is sulfide, and we'll call it SS. That's not a good name. Solid sulfur. Okay. Now let's give the other half nitrate. You should have to remember that. That's why I haven't put it here. NO3 minus is going to nitrogen monoxide gas. Okay. There's our two half reactions, but not balanced. But let's do the oxidation numbers and work out what's happening. So sulfur is -2 on that side and 0. So it's gaining charge, so it's oxidizing, it's losing electrons. And, okay, so for nitrogen here, so nitrogen plus oxygen equals 0. Let's assume that oxygen is -2, so N minus 2 equals 0, so N equals +2. And the nitrogen here, nitrogen plus 3 oxygens, going to be -2 equals -1. So nitrogen minus 6 equals -1. Add 6 to each side, nitrogen equals 5. So it's going from 5 plus down to 2 plus, so it's being reduced. So sulfide is the reducing agent. It's causing the reduction. And the nitrate is the oxidizing agent. It's causing the oxidation of sulfide. All right. I've gone a bit far down here. I might erase those. Change back to black. Okay, what do we do next? We balance these half equations. So we've got our sulfide going to solid sulfur. Okay, balance any non-hydrogen or oxygens. Well, there's one sulfur atom on the left and one on the right, so that's all good. Balance any oxygens, no oxygens. Balance any hydrogens, no hydrogens. Balance any charges by adding in electrons. Charge on the left is 2 minus, charge on the right is 0. So we need to add 2 electrons to the right-hand side to make them both equal to negative. Okay, that's our balanced half reaction there. Let's do the nitrate one. Okay, balance any non-hydrogen or oxygen atoms. Well, we've got one nitrogen on the left and one on the right, so that's all good. Balance any oxygens by adding water to the opposite side. We've got 3 oxygens on the left and 1 on the right, so we need 2 more oxygens on the right, so we add in 2 waters. Balance any hydrogens by adding in H plus to the opposite side. Well, we've now got 4 hydrogens on the right, so now we're going to have to add 4 H plus to the right. Sorry, to the left, opposite side, where I'm writing. Right and left. Oh, what am I writing? That's terrible. 4 plus H plus 4 H plus. That's better. Okay, 4 H pluses to the left. Okay, now we need to balance any charges. The right-hand side is all neutral, so it's 0. This left-hand side is 4 plus and -1, so it's 3 plus. And we need it to go down to 0, so we need to add 3 electrons to this left-hand side to get it down to 0. So now there's 4 minus and 4 plus takes it to 0. We're all good there. Okay, now let's look. Now we've got our 2 balanced half equations, let's look at the top one's giving up 2 electrons, but the bottom one's taking 3 electrons. So the lowest common factor for both of those is 6 electrons. So we're going to need 3 of these top ones to react with 2 of these bottom ones to get an equal amount of electrons being given up and taken. So let's go along and change our numbers. We've got a big 3 there, a big 3 there, and this 2 electrons is now 6 electrons. Okay, and this bottom one, this 3 electrons is now 6 electrons. This 4H plus is now 8H plus. 8, and there is now a big 2 in front of the nitrate. a big 2 in front of the nitrogen monoxide, and a big 4 in front of the waters. Let me just erase that 2 and a 4. That's a positive. That took out that 2. Okay, now we've got the top one giving up 6 electrons and the bottom one taking 6 electrons. We can add these two sides together. Switch back to black, hey? Okay, so we've got 6 electrons plus 3 sulfides plus 8 H pluses plus 2 nitrates. Okay, 3 sulfurs, 6 electrons, 2 nitrogen monoxides, and 4 waters. Okay, what can we cancel? Hopefully we can cancel our electrons. Yep, 6 and 6, that's good. Anything else? No, everything else is different from each other. So let's just rewrite it underneath as our final answer. Make sure we get our states in. We've got 3s, 2 minus, so 3 sulfides plus 8 protons plus 2 nitrates go to and produce 3 sulfurs, 2 nitrogen monoxides, and 4 waters. And there we go. And then there's just a grid pattern. Colour one in. Anyway, I'm being an idiot. End of the video. Thanks for joining us.